Hi, everyone. Today we are going to go over logarithms and exponential equations. I have a different screen here because I'm going to be using the calculator and try to show you how to come up with some exponential equations based on some data that you are given. So let's get started. First thing we're going to do is a little warm up. And in order to do this problem, we are going to have to combine these two terms here, simplify before we can use a change of base formula. So we have log base 2 of x times x minus 2 equals 3. We have the base to cross equal sign, so we have 2 to the third power is equal to x times x minus 2. That is quadratic. So we have x squared minus 2x. You're going to need to set this equal to 0. So you have x squared minus 2x minus 8. And then you have 0 equals x minus 4. You have x plus 2. When you split this up, hold on, let me fix that a little bit. When you split this up, you are going to get x is equal to negative 2 and x is equal to 4. You do need to go back up and check your solutions because remember your bases and your arguments do need to be positive. So when I plug 4 back in, I have 4 and then 4 minus 2, 4 works. So we have x equals 4. When I plug negative 2 in, that doesn't work. So that becomes an extraneous solution. You do represent it in your answer, but outside of the solution set because it's an answer, but not a solution. For this problem right here, we are going to do the same type of thing where we're going to combine these two, simplify. So we have ln of 4x plus 6 divided by x plus 5 because we are dividing is equal to ln of x. Subtraction means divide. If you have ln on both sides, you can eliminate those and you'll end up with 4x plus 6 divided by x plus 5 is equal to x. In this case, we're going to cross multiply and we're going to get 4x plus 6 equals x times x plus 5. And we're going to get 4x plus 6 equals x squared plus 5x. And we recognize that this is a quadratic. So we are going to set this equal to 0. And we get x squared, subtract 4x. So we have plus x, subtract 6 minus 6. Now I am going to factor. And so we're going to get x, plus 3 and x minus 2. Splitting that up, we get x equals 2 and we get x equals negative 3. Plugging that in, the negative 3 is not going to work because 4 times negative 3 plus 6 is going to give me a negative argument. So negative 3 is out. So my final answer will be x equals 2 with negative 3 outside as an extraneous solution. So what these are some practice problems. They are multiple choice. So if I were you, I would pause the video right now and then try to work these problems out yourself and then come back to it. So for this one right here, if you've had a minute to do the problems, for this problem right here, you're going to get 3 to the x minus 2 is equal to 3 cubed to the x. Bases are the same. I can set my exponents equal to each other. I have x equals 2 equals 3x. Subtracting x, I get 2x equals negative 2. X equals negative 1. There's my answer. For the next problem, let's see. This is telling me that log base a of 2 is going to be a variable and log base a of 7 is going to be a different variable. So what I actually need to do is to take 98 and split that out, break it down. And that's going to be 2 times 49, which is 7 times 7. excuse me, and that's going to be, let's see, log base A of 2 plus, I have 2 log base A of 7, so 2 log base A of 7. So log base A of 2 is x, so this is x. So we have x. This right here is going to be plus 2 times log base A of 7. That's y. So we have x plus 2y. Is that an answer? Here we go. All right. The last problem is asking you to condense it. And keep in mind, this using the power rule is going to go to this, meaning that'll be ln of the 4th root of x, plus ln of y, that's just times, minus, and this is again using the power rule, is squared. So that'll be over, let's see, z squared. So to me, this is the answer, but it looks very similar to this one, but I need you to understand this line here that's underneath the ln, that can't be there. So ln is, this is a quantity. See right here, this is a quantity where there's no line under the ln. Okay, expressed in terms of a sum or difference of a single log, or of single logs. So basically, we're going to expand that. So this is going to be log base A of x cubed, plus, because multiplication means plus, see the big times there, log base A of the square root of y, and minus log base A of z squared. And of course, I do need to simplify that a little bit. This 3 is going to come out front. So that'll be 3 log base A of x plus, this is y to the 1/2 power, so it'll be 1/2 log base A of y minus, 2 will come out front, 2 log base A of z. So this is just a lot of power rule here. If you are a little confused, you might need to watch an earlier video where I talk about log properties. Okay, so for this one, we're going to express as a single logarithm. So we want it to look something like that. So this is going to be log base A of, we're going to say the cube root of x squared minus 1 to start. And I would actually pull out a negative sign. And let me say that's going to be log base A of y plus log base A of z to the 4th power. Again, addition means multiplication. And in this problem, this is going to be log base A of the cube root of x squared minus 1. And see the minus sign? So that's divided by this stuff. But remember, plus now means times. And so this is going to be y times, what is that going to be? Y times z to the 4th power. And the only thing that I want to just fix is right in here, that A is not part of that. This is log base A of this whole quantity. So let's just keep this like this. Okay. This one, expand. So log base 2 of this. So this will be log base 2 of A minus this quantity, log base 2 of 3 times, times means plus, log base 2 of the cube root of B. So we could say the cube root of B, but I noticed that none of these did that, so I'm just going to leave it like that. So we have log base 2 of A, check, minus log base 2 of 3, minus log base 2. Okay, so it's this one, D. Now, is this a growth or decay? This equation right here is what we're going to be working on with our exponential functions and equations. So basically, this is a growth, and this came from 0.2 times 1 plus 0.45 to the x power. This is a growth, and this is my rate, 0.45, which became 45%. So it is a growth of 45%. So we are going to review our applications. We've been doing this in class, so this shouldn't be a new thing. But that being said, let's see what we do. We've got the number of cosmetic procedures in 1997 was 85,000. Since then, the number has increased exponentially at a rate of 95%. And so what we're going to do is we're going to first come up with an equation. We know that exponential growth is y equals a times b to the x power. B being our rate, A being our initial value. So we're going to start off with our equation, which is going to say y equals our initial value, which is 85,000, times B, which is 1 plus our rate, which is 0.95, to the increasing rate. We're going to go with time, or x. In this case, we have number of procedures, how many years. We're going to go with time. Okay, so this is our original equation. I can simplify that a little bit in that I can say y equals 85,000 times 1.95 to the t power. Find the procedures in 2000. So here's the thing. You are starting off at 1997, and now they're asking you to find the procedures in year 2000. That's only 3 years away. So you're not using 1997, you're not using 2000, you're using 3, because in this case, this is 3 years from now. So for this problem, you're simply going 85,000 times 1.95 to the third power, and plugging these in your calculator, you will get approximately 630,264. That's what I ended up getting. That should be something that you can do. We could do that online. We could do that. Calculate. We're just going to use a calculator for this. And for this one, let's see if I can work it together here. Maybe. So this is going to be 85,000. So let's see. Oh, I need my glasses. This is going to be 85,000 times 1.95, close the parentheses, to the third power. So you're going to use this little arrow up, to the third power, and then enter. So we have 630,264. The question then says, when will you get 4,800,000 procedures? So in this case, what they're looking for is 4800 with 3 zeros here, because that's 1,000, is equal to 85,000 times 1.95, and this is to the t power, because we don't know. That's the question. So the first thing you're going to do is divide, of course, by 85,000. So you're going to get 4800000 divided by 85,000. That's too many zeros. You're going to cancel some of those zeros. What do we have? Zeros go, zeros, zeros. So we end up with what we could have started in the beginning, which was 4,800 divided by 85, and that's equal to 1.95 to the t power. Notice that you have a variable as your exponent. You need to pull that out. We're going to log both sides. So we're going to go t log 1.95 is equal to log of whatever 4,800 divided by 85 is. And so t is going to approximately equal log of 4800 divided by 85, parenthesis, divided by log of 1.95. And so let's see what we get with this problem. This equals t, so let's see approximately. So if we use this, and we're going to say, we're going to go control to get the logarithm. I'm going to arrow over because I do know I'm in base 10. So in doing this, we're going to get 4,800. I'm going to divide that by log of 85, and I'm going to arrow over. I'm going to get an answer, which you're going to have to do approximately like that. And so we have 1.907, and that number is actually going to be divided by log base 10 of 1.95. So we're going to go log base 10 of 1.95, arrow over, enter. So I get 6.57. So approximately 6.57. So what that means is that's my answer, but it also means that it's almost 7 years is what it means. Okay, so moving on. Now this is the part where I want to show you how to create an exponential equation based on a table of data. So this one right here just basically says the percent of paper and paperboard that is recycled from municipal solid waste has grown exponentially. Use a calculator to fit the data within an exponential function. So we have data right here. We have 0, 21.6, 10, 27.8. And see, notice that I started in 1980. This is really important that you don't plug in 1980 because that's going to give you a super large value that you don't need. I mean, it's not going to fit on your calculator, but you can use it. It's just, it's better just to start at 0 because that's the year you're starting. So start it at 0. And that's also what you're starting at your project. So make sure you remember that. So we're going to start a new screen for this. And this is how you do it. You go to new document. The first thing you're going to do is you're going to go to lists and spreadsheets. So that's the first thing you're going to do. Now I'm using a TI Inspire CX CAS model. I think those are the best calculators out there right now. So that's what I'm using. Add lists and spreadsheets. First thing to do. You're going to notice you have a table here. So we're going to fill in this information. And so this might take a few minutes, but you do need to do that. You absolutely have to fill these two top boxes in. The first one we're going to fill in is with a year. And second thing we're going to do is I'm going to fill it in with the percent. Okay. And you do not want anything in these boxes right here. Do not put anything in these boxes. The next thing you're going to do is you're going to plug in your years, and we're going to, again, starting at 0 years, which represents 1980. You're not going to forget that. That's in your little chart right there. You're going to go down. Now you have 10, then you have 14, 15, then we have 16, 17, 18, 19, and 20. Keep in mind that you do have to click out of the 20. Then I'm going to go back up to the top, go to 0, and then I'm going to type in my numbers, 21.6, 27.8, 36.5. I'm going to plug in 40, 40.9, 40.3, 40.9, 40.9 again, and we have 45.4. And I do have to click down out of that. Okay, so now what I have here is my information on my chart. Now, there's two ways that I can get my equation, okay? The first way to get my equation is basically to, once I'm here, okay, I would go to menu, and I roll down to statistics, and I do stat calculations, and then I do exponential regression. And what that does is it says, okay, name your x-axis. Now my x-axis is my year. So if you click on this little arrow right here, you're going to see I have percent and year. So that's year. X is year for me. My list on the second one is going to be percent. And I go, okay. And what it does here is it gives me my A and my B. Okay, it gives me my A and my B. Here's A. Now keep in mind, okay, I'm going to write this down somewhere. Let's see if I can split this up somehow. Let's see here. Remember your equation. Okay, so I'm logged on blue. Y is equal to A times B to the X power. Well, they gave me A. A was, let's see, 21.1388. So A was 21.8388. Is that what it said? Yeah. 88. And then that equals Y times B. B is 1.03847. So 1.03847 to the X power, which I'm going to call T for time. So that's one way to find that equation, okay? However, another thing that you can do is once you're in the table screen, so you're going to click on Control and then Doc. So we're going to go Control, Document. And when I get that, I'm going to roll down to where it says Data and Statistics. And what that's going to do is I'm going to get a scatter plot. And so what that's going to do is I'm going to go click to add or enter a variable. And remember, I put on here year was my x-axis. And all the little dots are going to go down to year. And then I'm going to click over here where it says click to add the variable. This is going to be percent. And now I've got my exponential scatter plot there and my data in. So now what I need to do is I need to click on menu. And then I'm going to analyze my graph and go to where it says regression and roll all the way down to make it an exponential equation. Because I can make it any of these things, but we're going to make it an exponential equation. And now what they've done is they've given me an exponential equation. That's because you can very clearly probably even make it a line if you asked it to. But we're making it an exponential equation like this. And this equation, if you notice, is actually the same equation here. So this is how you come up with the equation. I gave you two options, okay? And so if you notice that that's actually posted online, so with all pictures and all that, and you can look at that if you need more step-by-step instruction. So now that we have our equation, okay, that's the first step. Use the calculator. Use the calculator to fit the data. So we just did that. So this is our equation, okay, right here. All righty. I don't want that. Let's see. Let's get rid of that. And I'm going to try to move this over here a little bit. Move. Okay. And let's see. So we're going to close this. We have to the T power. And so next thing is we're going to estimate the percent of paper that'll be recycled in 2005. Well, if you notice that 2005 is way down here. So we want this value here that's going to come in 2005 is going to be 25 years. So that's the number I'm going to plug in to get. So I'm going to go y is equal to 21.8388 times 1.03847 to the 25th power. Okay, plug that in your calculator and let's see what I got. I think I already did this. You can plug it in. You should get y is approximately 54.3%. So that's the percent that you're going to get for this problem. Now, in what year will the percentage exceed 70%? So with that problem, we actually set y equal to 70, 21.8388 times 1.03847 to the t power, because we're solving for t because we're trying to figure out the time. First thing we're going to do is divide both sides by 21.8388. And then after we do that, we're going to log both sides. We are going to end up getting, let's see here, like 3 equals, let's see, I ended up, I believe when I all said and done, these canceled. I got this number. I had to log both sides, meaning you're going to go t log or ln. Either one will work. You're going to get the same answer. 847 is equal to log of whatever 70 divided by 21.8388, etc. And when you get that, and then you divide both sides by this value here, you should get t is approximately 31.72. And what that means is in what year will the percentage. Now, so 31 is not a year. So you're going to have, this is 25. So add another 31, add another, 5 years, that's going to be 30. So now I'm at 2010, and then add another 1.5 years. So it's like 2011. So in 31 years, we'll have 70% of the paper recycled. So that's kind of cool. So another thing that you should be practicing is graphing equations, because both of these are going to be on your test. You do need to make sure you know how to do this. I always recommend to start with what we call the parent graph. And in this case, the parent graph is y equals 1/4 to the x power. You are going to plot some points for x and y. You can plot, I usually tell people to plot 0 and 1. 1/4 to the 0 power is 1. 1/4 to the 1 power is 1/4. So we do have 2 points. We have 0, 1, and 1, 1/4. And this graph, being an exponential that is decreasing exponentially. Now, a couple of things. All we did was graph the parent graph. Now, what happens to this value right here is that reflects across the x-axis, okay? That reflects across the x-axis. So what that does is it's going to mirror it this way, okay? And it's going to look like this. So after that, this value right here is going to move my graph to the right 1 unit. And so now my points will be over. And so this graph will now look like this. The +2 will take the entire graph that I just moved over and move it up 2. So in this case, this graph right here ends up having 2 points here and here, 0, -2, and 0.5-ish 0. And it's really, really important and in your best interest to, as you're moving your points, to plot those and to maintain where you are at all times. For this problem right here, we're going to start off with the parent graph, which is 4 to the y is equal to x. We're going to plot for x and y. But if you notice right here that the exponent is y, that's where I'm plugging in my points. See how my exponent was x? See how I put 0 and x, or 0 and 1 here? That's what I'm doing with my exponent. So plugging in 0, 4 to the 0 power is 1, 4 to the 1 power is 4. So my 2 points starting off are 1, 0, and 4, 1. This is a logarithmic equation, which you know logs go over here to the right. This right here is going to move my graph 3 units to the right. So again, take your points, move them over to the right. Very, very important to do that. Keep track of where your points are going to the right and then up 1. Okay. Please make sure you do that. Uh-oh. Let's see, I just lost that. Okay. This, just keep in mind, watch where your points are. For this one right here, again, if you remember we just did something very similar to this, y equals 1/4 to the x power. We plotted 2 points for x and y. We plotted 0 and 1, and we got 1 and 1/4. So 0, 1, and over 1, 1/4. So this graph, which is an exponential equation, does decline and decay like that. This negative x up here reflects across the y-axis, okay? So in this case now, this graph is now going to look like this, okay? This point that was here is now over here. This point being on the axis, the y-axis still stays the same. -2 is going to take my graph and drop it down 2 units. Again, please be very careful that you, okay, I can't get that over there. Please be very careful, there we go, that you maintain your points, okay? This one right here, we're going to start off, it's going to be 5 to the y power base to cross the equal sign is equal to x. We're going to plot 2 points for x and y, but the points that we're going to plot are 0 and 1 under y. 5 to the 0 power is 1, 5 to the 1 power is 5. So we have 1, 0, and then we have 5, 1. This being a log equation is going to do this. This value, you do your reflections first. This value is going to reflect it across the x-axis. So what that's going to do is make it look like that. This point now is down here. This is going to move my graph to the right 3 units. So moving over to the right 3 and then up 4. Again, keep track of your graphs always, and those points, keep track of those. Very, very important. So I hope that helped you on the calculator aspect. I hope that it helped you on all the logarithm review and also the graphing review. And thanks for watching. I'll see you next time.